Hello everyone. So in previous I described the inverse of the matrix with simple method and the Gauss-Jordan method. So it is also known as the elementary and column operation. Okay. So our new next topic is also related to similar to this. Okay. So in this I tell you about the how find the rank of the matrix. So this is also a very important topic, so please focus on this. Okay, so start from the rank of the matrix. Okay, so it is very easy. So what is said, uh, it has at least minor of order r is different from 0. Leave all the things, I tell you this thing in simple way. Like there is any matrix, it is a1, okay, a2, a3, b1, b2, b3, c1, c2, c3. Okay, it is a matrix, or it is 3 into 3 order, means there is any matrix of m and in m and n order. Okay, any matrix. So first we need to eliminate this matrix like this. Okay, so same thing, we eliminate all these things. Okay, what we make, we make this matrix like I. Okay, so same here we do these things like when any matrix, so we convert, we as much as possible we make rows and columns is equal to 0, but first element is 1. Okay, so now continue. So there are some properties, so if you want to go through this, so I tell you. Okay, so some properties. Number first is, if a matrix is equal to a ij, okay, with the order m and n, okay, and matrix b is equal to v ij with the order m and n, m into n, then this thing present the range. Okay, it is a row sign, so it presents the range of the matrix. So the range of the matrix a plus b, it is less than or is equal to range of matrix a plus range of matrix b. Mean it is less than or is equal to. Okay, so and now second property, if means this is the same thing, if a matrix is in the form aij into m into n, and the matrix is in the form of vij into, now it is changed, n into p. Okay, then the range of matrix a into b is less than range of matrix a, and range of matrix ab is less than or is equal to range of matrix b. Okay, so it is second. So third point is, now see here, if there is a matrix A, it is equal to, means it is in the form of aij into n, means like I write 2 into 2 matrix, 3 into 3 matrix, 4 into 4 matrix, like this. Then the range of the matrix of A is equal to the same as the range of transpose of the matrix A. Okay, so it is equal. Now you can see this thing. Okay, it is AB. So now I try to understand you why a example, because example is a good thing to understand to someone. So let's take, so we need to find the range, okay, of a matrix A. Means there is a matrix A, 1 3 minus 1 2 minus 3 1 2 minus 6 2 4. Okay, this is a matrix. Now we do same thing uh, like this. In previous question we eliminate rows. Okay, so same thing we do here. So again see here that how I do. So now apply R2 is tells to R2 plus R1. Why I write this? If I add R1 in R2, then it is 0. This element is 0. Okay, so we don't convert this row. Okay, only we need to convert this. It is remain first here. Okay, and after that convert all these. We don't worry about this. So first I convert row second, and row third, just R3 plus 2R1. Okay, how see here, it is 3, it is minus 6. If I multiply by 2 in this and add this, so it is 0, and it is also 0. So see next matrix. So A is equal to 3 minus 1 2, or I can change my pen. So A matrix is equal to 3 minus 1 2. Okay, after that multiply by or add these two, so it is 0. Okay, and it is 0 and it is 4. Okay, now it is 0 and it is also 0 and it is 8. Okay, now see here again I apply R3 is R3 minus 2 R2. Okay, so what I get now? So it is 4, it is 8. If I multiply by 2 in this R2 and subtract from the R3, so I get it is 0. So A is equal to 3 1 minus 1 into 0 0 4 0 0 and 0. Okay, after that again I apply R1 is 1 by 3 R1. Okay, so I told you that we convert it also in replace it by 1. So if I divide this row by 1, then it is 1. Okay, so after that, so it is 1, and I also reduce it. So R2 is also 1 by 4. If I divide this row, okay, by 1 by 4, then it is also 1. Okay, so I can add this statement and apply it in next step. So A is equal to, what is here, 1 minus 1 by 3, 2 by 3, 0, 0, 1, 0, 0, 0. Okay, so stop here. Now there is one another thing. What is it? So another term which is known as echelon. Okay, so what is happen in it? So it is a matrix, also matrix. Okay, so in what happen in this? So like there is an any matrix, zeros are increasing in each row, means zeros are in the increasing order. So it, if zeros are in the increasing order, then it is known as echelon. Okay, so echelon form of the matrix. So you can see that it is the increasing form of 0. Okay, first 2 and after that 3. So this matrix, now this matrix in the form of echelon. Okay, so now what happened? So I also tell you before some time that the non-zero rows, now there is 1 and 2, two non-zero rows are left. So the rank of the non-zero rows is equal to the rank of a matrix. So rank is equal to number of non-zero rows. Okay, if I try to also means try to convert to 0, so when I minus this thing, so it is minus from these things, this is also changed. So it is the means last I don't convert it. Okay, so it is the rank is equal to number of the non-zero rows. So it is equal to, I can write is as, okay, so this is the main thing. If you want, so now I tell you something about echelon. Okay, so it is a matrix. Like a matrix is said to be echelon form if there is some condition, means if the first non-zero element in each row is 1. Okay, the first non-zero element in the each row is 1. So you can see here that it is 1, it is 1. Okay, so therefore it is a echelon form. And the second condition is every non-zero row, every non-zero row in A precedes every zero row. Okay, and third condition is the number of zeros before the first zero row, the number of the zeros before the first zero row, first zero, or I can write a not row, it is element. So in first row means it is come in the first row when first element come in the first row, so I can write element. Okay, so in first, second and third, like any rows should be in increasing order. Okay, so now you can I give some examples here. After see this you can able to understand. Okay, so see here, like there is a matrix 1 2 3 and 0 1 4 and 0 0 1. Now you can see here that the first non-zero element is 1, that it is 1. Okay, so this row start with 1, this also 1, this also 1. Okay, that after that every non-zero row, okay, non-zero in A predict every non-zero row. Okay, so it is also. So in third, the number of zeros before the first zero element, okay, in first second third row should be in the increasing order. You can see here that it is also increasing. Okay, first in this there is 1 2, and here I also take an example of a big matrix, like there is a matrix 1 2 3 4 5 0 1 2 4 3 0 0 1 2 5 0 0 0 0 and 0. Okay, so now you can see here that this in this row, okay, in this row it is start with 1, in this row it is also start with 1, in this row it is also start with 1. So you can check the points. Okay, after that 0 in the all rows are increasing respectively, that in the first row it is 1, in the second row it is 2, in the third row the number of the zeros are 5. Okay, there is no condition. If I take that there is another 1 2 1 2 3 4 5 0 1 2 3 4 and 1 2 3 4 5. So this is not come in under this. How? Because it is also start with 1, but the 0 is decrease here. Okay, and I also take an example. See here that there is a number 1 2 3 4 5 0 1 2 3 4 0 0 2 3 4. So it is not also come under this. Okay, why? because it is start with 1, good. It is 0 come and start with 1, good. And 0 0 it is increasing, good. What it is start with 2, and the one first condition, what is it? The first non-zero element in each row is 0. Okay, so I hope you understand also this term. So it is help in the, this term is help in the to find the, when we find the um, range. Okay, so I hope you can understand this thing. So in the next video I start with the Einstein values. Okay, so this the next topic is also very important. So I hope you can enjoy and do practice yourself and from the questions, and I also provide some PDF for you to do practice on these questions. Okay, don't worry. Thank you. Have a nice day.